Hello students, let us see this problem from JEST 2013 question paper. So in this problem, they say a simple model of helium-like atom with electron-electron interaction is replaced by Hooke's law of force and described by the Hamiltonian. And we need to calculate the ground state energy. Now, if you carefully see this expression, this is the expression for two harmonic oscillator. This is the kinetic energy term, this is the potential energy term. And if I open this term, this will give me R1 square, R2 square, and 2 R1, R2. That means now the coordinates are coupled. So we cannot solve in this way. So let us make first this equation decoupled, and then we can write the ground state energy. For this, let me put the substitution. Say R1 is equal to 1 by root 2 U plus V, and R2 1 by root 2 U minus V. Now this will give me R1 square, which is R1 dot R1. If I make it a square, vector square is the equal to mod square. So this will give me U square by 2, V square by 2, and this is half. So plus U dot V. Similarly, if I make it R2 square, this will give me V square by U square by 2 plus V square by 2 minus U dot V. I want R1 square plus R2 square. So R1 square plus R2 square will be simply U by 2, U by 2. So U square plus V square. So this is all. Now I want R1 minus R2. So I do R1 minus R2. So I can see R1 minus R2, this will be cancelled and this will be adding. So this will be equal to root 2 divided by root 2 V. So that means 2V. And the mod of R1 minus R2 will be root 2V. And now, so this I can write, I can use this one. And now we have a del square, Laplacian square. So del 1 can be written as a, because this is a linear transformation, so I can directly write this will be equal to 1 by 2 del U plus 1 by root 2 del of V. We can easily show this one, and simply del 2 will be 1 by root 2 del U minus 1 upon root 2 del V. And now if you make it a square del 1 dot del 1, that is del 1 Laplacian, that will be simply, this will be 1 by 2 del 2U plus 1 by 2 del V square, and then the term will be here, say del U plus del V. Similarly, del 2 square will be half of del U square plus half of del V square minus del U del V. So you again, if you add this one, del 1 square plus del 2 square, I want here, this will be simply del U square plus del V square. If I add these terms, now just we need to put the substitution here. So if I put the substitution here, my equation will become minus h cut square upon 2m del U square plus del V square, and this will be simply half m omega square. Okay, omega square, and then you will be having R1 square plus R2 square, U square plus V square. Okay, u square plus v square. So u square plus v square. And now here we have a lambda by 4 m omega square, and this has become square. R1 minus it is root v, so this become 2. There will be 2v, 2v. Okay, so here we have the equations. We were having the equation here, and this one. So square we make, this will be 2v square. So this will be 2v square. So this is the u square plus v square. And now I have a minus lambda upon phi omega square, and this become 2v square. Okay, now this equation become decoupled. So now I can write this equation as a minus h cut square 2m del u square plus half m v square u square plus minus h cut square 2m del v square plus half m v square omega square. If I take common, this become 2, so this become 2, and half I'm taking common, so this become 1 plus this become lambda. Sorry, this is make a minus half common and common, this common v square common, so you have only 1 minus lambda left here. And now this we can write as, so this is the frequency omega square, and here frequency become omega 1 minus root 2, 1 minus root. So here the frequency is omega, and here the frequency is a omega dash, which is equal to omega root 1 minus lambda. Okay, I'm considering this inside the frequency angular frequency. Now these are two decoupled harmonic oscillator. The total energy will be what? Ground state energy of three-dimensional harmonic oscillator. This is 3 h cut omega, and this will be 3 by 2 h cut. Instead of omega, we have omega 1 minus lambda. And if I take 3 by h cut omega common, so this becomes 1 plus 1 minus lambda. So this is my correct expression for the energy. Hope you like the solution. Thank you very much. Please like and subscribe my channel.